Good morning, everybody. So we had a small problem at the beginning, so I had to test videos. My name is Anil Ufuk Batmaz, and I am a postdoc at the Professor Wolfgang's laboratory. And today I'm going to talk about the stereo display deficiencies in AR and VR. So this is a previous work done in our lab by Mayra. Mayra is one of our PhD students, and basically she did an experiment in 3D stereo large display by movements in the wave direction and in the lateral direction. And she compared these results with the real-world movements by using a fit-slope task. And she found significant differences between these movements. And in our research, we asked a similar question, that do we have the same differences in VR and AR headsets? So I told about the motivation. In our previous work, we found that the change in the visual depth affects user performance negatively. The other thing is that we've been talking about this in the last 2 days. I'm not going to go into details, but when it comes to VR and AR headsets, the users can overestimate or underestimate the distances. The other problem is the accommodation and divergence difference issues. In the real world, we can focus on the different objects in the different distances, but when you are using a AR or VR HMD display, that you have to look at one display, which limits your focusing. So we had two motivations. The first one is we are expecting to have a better speed and throughput with the AR headset. Because in the augmented reality, you can see also, in addition to virtual world, you can see the real world, and we were expecting to have this additional visual depth cues can help user to get a better performance. The second thing is, based on Mayra's previous research, we were expecting to have a negative impact on the user performance when it comes to depth change. So we use two different headsets for VR and AR. For VR, we use HTC Vive Pro, and for AR, we use Meta 2 headsets. The reason to choose that two headsets is we have two reasons. The first one is we wanted to replicate Mayra's previous experiment. So we needed a large field of view headset. And based on this, we tried to choose two headsets that can reduce the specific differences, the feature differences, like field of view, the weight, and the refresh rate. So we tried to choose the two headsets similar to each other. Then we didn't use the VR and the AR headsets tracking system. What we did, we used an external tracking system by using OptiTrack. So the reason is the VR headset, the HTC Vive Pro, is using two lighthouses and a built-in system to track the position. But the Meta headset is using the RGB cameras and infrared sensors to get the position. And these can produce different delays, different latencies, and we didn't want to deal with this problem, so we used an external tracking system so that we can have a fair comparison. We also used a wand like this so that we could track the user pointing. On this one, we had a small push button that is not a click button. You just push the button so that we didn't have any Heisenberg effect. And we asked subjects to perform this experiment. We spent about more than 1 month to calibrate both VR and AR headsets. I'm not going to go into details of the calibration process, but what I can say, we didn't start our experiments until we were sure that distances in the virtual environment match to real-world environment. So we used a VR headset, we used an AR headset, and we had movements in the view direction that going further away from the user or coming closer to the user, to right and to left movements. And we replicate the same fits law of task in the Mayra's previous study, that we use the same target distances and the same target widths. So here we have the movement time, error rate, throughput, and the target reentry results. But because these all the dependent variables show similarity, I'm going to just focus on the throughput. So if you look at the minus 90 and 90, this is the movements to left to right, you could see that the throughput is higher compared to movements from further away and getting closer. So we can say that the lateral movements, that movements left to right, is superior to wave direction, and we had the same results for both movement time and for the error rate. The other thing is that if you look at this zero is the movements getting further away from the participant, and we had the least throughput for this movement. And we had, again, same results for movement time and for the error rate, that the subject's performance were getting worse when they go further away from themselves. So we also look at the device differences. Maybe you can guess the movement time, the error rate, I don't know, but we couldn't find any significant difference except for speed. So in our results, the pointed movement in augmented reality was faster than the VR headset. We said, okay, let's go in the deeper and let's explore the movement path, that how was the movement path was changing. And we found that the subjects started to do more movements in the virtual reality, and they were doing more pauses in the virtual reality. When we look at the correction phase, we saw that subjects were doing more correction movements in the virtual reality, and their correction speed was lower in the virtual reality. So we can say that correction phase is less efficient in virtual reality. Other results for the interaction. So if you look at the left, we have the error rate results. And this blue column here shows our AR results, and the red column is our VR results. If you look at the 0 and 100-degree movement, this is going further away from the user or getting closer to the user, you can see that the subjects did more error with the VR headsets. The other thing is, when you look at the throughput results, for the movements for going further away and getting closer to user, that the subject's throughput were less with the VR headset, but for minus 90, for the lateral movements, from left to right movements, we had the reverse effect. So, discussion. The first thing we were hypothesized is that we were expecting to get a better speed and the throughput with the AR headsets. And it was partially true. So, do you remember that results that we found the subjects were a little bit faster for the speed in the AR headset. And we found that the subjects were doing more movements in the virtual reality, and their correction phase was less efficient in virtual reality. Why we had these results? Well, we can come up with the hypothesis. Maybe the subjects were able to see their limbs, and they could get more motion parallax from the real world, or they were feeling more comfortable when they see their hands. These are all speculations. They have to be looked at. Or in the virtual reality, for example, we had the different pictorial cues because the environment is completely virtual. The texture, the lighting, shading, all this could affect the user performance. The other thing is that we were expecting to have a negative impact of the depth change on the selection performance. And we had these results, that with the target change time, that the subject's performance started to get worse. When we also look at the throughput, we saw that, especially if we had about 20% less throughput with the wave direction movements. So, in conclusion, first of all, we need better headsets. because when I said it to Mayra's the first experiment that we found the significant differences between the stereo display and also the real world movements, and when we extend it to the virtual world, we still get the same results, that the user performance decrease when we use stereo displays when it's compared to real world. The second thing is VR and AR headsets show similar effects. And the perception effects, yes, affect the virtual reality a little bit more, but for the movement type, throughput, or for the error rate, we have the same results. We also confirmed our Mayra's previous research, saying that yes, the depth change has a negative effect on the user performance. And the last of all, it's important to investigate movement trajectories. As you can see, that we found a significant difference for the speed, and when we go deeper into the movement path analysis, that we found more results that can answer our questions. So thank you very much, and I will be really happy to I will be really happy to answer your questions. Thank you very much.
Time for questions?
I have one more slide that I am looking for a faculty position, and Mayra is looking for a postdoc position that I would be really happy to talk about this.
Any questions, please step to the microphone.
Hi, I was curious if you looked into how the latency of the VR headset could have affected the movement speeds. So, like, I guess if you want to touch on that, was there any latency that you saw or have seen in the VR headset that could have affected the speed results?
Well, first of all, we didn't observe any kind of latency yet. One of the issues that we know, the virtual reality headset use the IMU to reduce the latency. But since we didn't use the built-in IMU of the system, and we didn't explore the IMU effects, we eliminated this. But the main reason is to use the external system to be able to have a fairer comparison between two headsets. In our case, that we didn't observe any latency that might affect the user performance.
Okay. Thank you. Very good work.
I have a question. So your hypothesis was that AR would be superior in some of these tasks because of depth cues, yeah, right? Improved depth cues. But the task was to reach to virtual targets, right? And I might counter-hypothesize that in VR, the virtual target and the virtual hand, which are the important things in this task, both have the same incorrect depth cues, the same accommodation divergence problem. Whereas in AR, we have a mismatch between the accommodation to the virtual target and the real hand. Mm-hmm. So could you comment on that? Or is there some other difference maybe between AR and VR besides the accommodation divergence conflict that explains your results?
So that as we talk about the experiment, that we are aware that in the virtual environment, subjects that just saw a virtual wand that going to forward, backward, or left to right. But in the augmented reality, addition to the real one, that they were able to see their hands, their limbs, and this is why we hypothesize that it will improve the user performance, because they will get additional cues. Yes, we included that as a for the mismatch, and for this was one of our motivation to start the experiment, that we know that there are mismatch, underestimation or overestimation in the depth. But one of the things we want to do, that we compare this with the real world experiment, and to show that we still need a better performance or the better displays.
All right, I think we're at the end of the time for this talk, but thank you very much. Thank our speakers again.